Hello, Miss LaHart here coming at you with Chapter 11, LT4. I can work the 6 trig functions like a pro. Did you know there's 6 of them? Oh, yeah. Okay. There's a lot of vocabulary in this unit. Okay. I'm going to say the ratio of a lot. And when I say ratio, I'm talking about like the trig functions are all ratios of side lengths of a right triangle. So a ratio is a comparison of two numbers, a fraction, if you will, comparing two numbers. Okay. Trigonometry, branch of mathematics that studies the relationship between the sides and angles of triangles. Trigonometric functions are functions of an angle. They describe a certain ratio of right triangle sides based off an angle measurement. So this is very useful in real life because given an angle of elevation, you can tell me what the sides are. You could expand them. There's so much like practicality in this. It's great. Distances, angle measurements. Okay. The 6 trig ratios, you know the first 3, sine, cosine, and tangent. Okay, sine, cosine, and tangent. And then the next 3 are called the reciprocal trig functions because the reciprocals of this. Sine's reciprocal is cosecant, cosine is secant, and cotangent. So sine, cosine, tangent, cosecant, secant, and cotangent. Okay. So the right triangle definitions of trig functions, here we go. So given a right angle, so we got ourselves a right angle right here. We're going to put theta, the angle measurement right there. That would mean that this is the opposite side. That would mean this is the hypotenuse, and this would mean this side is the adjacent side. Okay, so Katoa, you know those ones. Now, what are the reciprocal trig functions? So reciprocal of sine is cosecant. Okay, so cosecant is the flip of sine. Okay. Cosecant is very close to Santa, if you will. Cosine is reciprocal function is secant. That is the ratio of the hypotenuse length over the adjacent length. Secant's the funny one. And cotangent, okay? Ayo, I don't know how you know what I mean? It's just the reciprocal, the flip of them. One of the tricks I tell kids to remember which one goes with which one, the S's and the C's go together. So sine, cosecant, cosine, secant. You know what I mean? I can build this side. I know this by heart, the good old SOHCAHTOA. And then this side just kind of takes me a second. I just got to think about reciprocal trig functions. Okay. All right. A lot of beautiful conversations can be had, and I need to get rid of this. Sorry. Who's positive where? So if you think about it, okay, we've already went over that sine is the ratio of the y over 1. So cosecant is 1 over y. Cosine is the x over 1. Secant is 1 over x. Now, tangent, I forgot to go over this in my, tangent is the y over the x. Because think about it, it's the opposite side over the adjacent side. So tangent's the y over x. So cotangent is the x value over the y value. That's basically what there is to it. Okay, who's positive where? So here we go. So think about, okay, in the first quadrant, x is positive, y positive. So that means, and then in this quadrant, we have x is negative, y is positive. Negative, negative, positive, negative. So in regards to this, who's positive where? So everyone's going to be positive in the first quadrant because both x and y are positive. In the second quadrant, only the y values are positive. Therefore, sine and cosecant are going to be positive in this quadrant. Negative, negative, the only way to get that is to divide a negative value by a negative value to get a positive value. So tangent and cotangent are positive in 3. And then we have the x, which is cosine and secant. One of the ways we memorize is all suckers take calculus, all suckers take chemistry. There's a bunch of other ones. Again, sine and its reciprocal function, tangent and its reciprocal function. This is a shortcut of who's positive where. Okay, because it's good to know. Okay. Oh, those are my marks. Jeez. My apologies, Miss LaHart doesn't know how to work a computer. Okay, that was just my stuff. I was like, oh, I gotta get those lines out. Okay. All right, so here we go. So if I give you a coordinate point, can you tell me the ratio of the side lengths? Use the given point on a terminal side, angle theta, to find the value of the trigonometric function. So first, my advice would be to draw yourself an x and y axis. Put yourself on that coordinate. Okay. So x distance is 3, y distance is 3 because of the coordinate point. They want to know the ratio of sine of theta, which sine of theta is the opposite over hypotenuse. I have the opposite. I don't have the hypotenuse. So what am I going to use? Good old Pythagorean theorem. A squared plus b squared equals c squared. So in this case, it's going to be 3 squared plus 3 squared. So I get 18 squared. 18 equals c squared. We want to, how do you get rid of a square? We don't want c squared. We want c. So we take the square root of it. Okay. We got to remember how to rationalize or simplify a radical, excuse me, the square root, the perfect square that can go into 18 is 19 and 2. So that becomes 3 radical 2. So I know that my hypotenuse is 3 radical 2. So when I put the opposite side, which is 3, the hypotenuse length, which is 3 over radical 2, now we have to go ahead and simplify, okay? Here, fraction sense, the 3's would give you 1. Now this is taking us back. Okay, how do we rationalize the denominator of a fraction? You multiply top and bottom by the denominator, because in this case radical 2 times radical 2 is just radical 4, which is the square root of 4, which is 2, and then on the top you would just have radical 2 over 2. Okay, so therefore the answer to this question is the sine of theta is going to be equivalent to radical 2 over 2. So we know it's a 45-degree angle. But anyway, all right, there's our first example. Okay, cosine, we have the coordinate point 18, -2, so drop yourself where you are. Okay, x is 18, y is -12, so that triangle would look like that. Cosine is opposite over adjacent over hypotenuse. I have the adjacent angle, that would be the 18. I have the adjacent side, excuse me, I misspoke. I got to go after the hypotenuse. So therefore, I'm going to use good old Pythagorean theorem to help me out with this. 18 squared plus -12 squared is 468. Okay, simplify your radical. You got to take the square root of both sides. Okay, looks like I don't have to get rid of c squared. We take the square root, take the square root. Okay. The perfect square that can go into 468, if you didn't see it already, is actually 36. So this becomes 6 square roots of 13. So there's my hypotenuse. Ooh, Nelly, this is going to be fun. Okay. The adjacent side length is 18. The hypotenuse length is 6 radical 13. So now I reduce this. I'm going to end up with 3 over radical 13. Hopefully you can get that far. Now we have to rationalize the denominator. So we're going to multiply top and bottom by the radical. Whenever you multiply a radical by itself, it's just going to be in the top 3 radical 13, in the bottom 13, and that is your final answer. The cosine theta of this angle measurement is going to be 3 radical 13 over 13. Okay, you guessed it, tangent is up. Tangent is up. Okay, let me get rid of that. Here we go. Here we go. Okay, tangent's lovely because you don't have to do Pythagorean theorem because it doesn't matter if they don't want the hypotenuse length. So here we go. We've got -6 radical 13. Again, -x, positive y, boom. Tangent of the angle would be the opposite side, which in this case will be radical 13, over the adjacent side, which would be -6. And that's it for that one. Tangent's the nice one because you don't have to use the, I mean, it's a quicker one, excuse me. It is faster because you know all the information you need. Oh, next one. Here we go. Wait a minute. All right, I'm back. My apologies. I had an issue with my PowerPoint I had to fix. So, 3 more examples. Again, sine of theta. Draw where your triangle is. We have, if the coordinate x is 2, y is -2 radical 3. Sine is the opposite over hypotenuse. Again, we have to use Pythagorean theorem. Okay. I'm hoping that some of you can do this in your head. Again, you can always resort to your calculator. Just be careful how you plug this in. 2 squared is 4. This is going to be 4 times 3, which is 12. 12 plus 4 is 16. Ooh, we like that number. Why? Because what's the square root of 16, everybody? 4. Okay, so therefore, opposite side would be the -2 radical 3. The hypotenuse length would be 4. Reduce if you can, so we would have sine of theta is equivalent to radical 3 over 2. Okay. All right, cosine again, draw where you are. This is in the first quadrant. Again, x is 7, y is radical 15. Cosine is adjacent over hypotenuse, so you have to use your, again, Pythagorean theorem. 49 plus 15. Oh, another one. We get 64 equals c squared. Square root of 64 is going to give you 8, and then that goes there. So adjacent to 7. And the hypotenuse is 8 in this case. So cosine of theta is equivalent to 7 over 8. Okay. Ooh, tangent again. Remember, tangent's kind of the easy one because you have the information you need. In this case, again, tangent is the opposite side, which is negative 18, over the adjacent side, which is negative 17. Simplify if you can. So the only thing I could do there is simplify the negatives out to give you a positive 18 over 17. Okay. Go to the classwork. I didn't have any of the reciprocal functions, so we're going to do 3 of the reciprocal function questions on your classwork. Again, page 13, we're going to do 7, 9, and 13. Okay, so reciprocal. Okay, so for the first one, my x distance is 2 radical 3, my y distance is negative 2. Cosecant is the h over the o. So I don't have my hypotenuse, I have the opposite. So therefore, I'm going to use Pythagorean theorem. 2 radical 3 squared will actually give you 12. This will give you 4. So we got 16. This one's a nice one. Again, C distance would be 4. That goes there. Hypotenuse is 4. Opposite side is negative 2. 4 over negative 2 reduces to negative 2, baby. Love that for us. Okay. 8. Nope, 9. Doing the odd numbers. Secant of 6 over 3. So again, draw where you are. So in this case, we go 6, 3. Okay. A secant is the reciprocal of cosine. Uh-oh, where is it? Okay. I don't know why it's not popping up first. I gotta fix that. So secant, I'm so sorry for my handwriting right now, of theta, just so you know, is the reciprocal of cosine. So this one's the funny one, h over a. Okay, again, the only need I need is the good old Pythagorean theorem in order to get that hypotenuse. So 36 plus 9 does give me 45. So simplifying that radical would end up being 9 times 5. So 3 radical 5. Okay, I should have put that. Let's bam. Okay, so therefore that is now our hypotenuse length, thank goodness. So where is it? There we go. 3 radical 5 over 6, which would end up being radical 5 over 2. And there it is. Saved it till the end. Okay. One more. Cotangent, which is the great one. Again, draw where you are. Okay, cotangent is adjacent side, so that's 17 over the opposite side, which is 2, and we're done. Okay. Simplified, beautiful, Miss Lahar out. Okay, go ahead and do your classwork. Have a great day.